So let's see this. Okay. So when you're doing a contingency test, this is called a contingency table. I always make my tests going across, because then if you want to find positive, what we're talking about, true positive, true negatives, like we were talking about the last class, you can use the totals below as long as your test goes across. And then this would be total positives, total negatives. So we did a few examples last class, but I wanted to do a couple more with the tests. So if we look at this one, this is problem number 3. Oops. I don't know how much space I need. There we go. In a certain region of the country, asymptomatic women between the ages of 40 and 50 are invited to participate in breast cancer screening, mammography. The probability that a randomly selected woman from this group has breast cancer is 0.8%. If a woman has breast cancer, the probability is 90% that she will have a positive test. That is, the sensitivity of the test is 90%. If a woman does not have breast cancer, the probability is 7% that she will still have a positive test. That is, the selectivity of the test is 100 minus 7, or 93%. Imagine that you are the medical advisor to a woman who has learned she has a positive test. What would you tell her is the probability that she actually has breast cancer? And so once we set up the table, we would be finding this probability. Remember, this line means given. So given that she had a positive test, what's the probability she has cancer? And we'll look that up once we fill in the table. Now, the one thing they didn't tell us is the total of people who are going to be in the study. So we'll go with 10,000. Just so we have enough size, but less likely to have half of a person in a test. So if we go with 10,000, looking back at the question again, it said the probability that a randomly selected woman, that means out of all 10,000, has breast cancer is 0.8%. So the total is 0.8% that have cancer. Now 0.8 written as a decimal, 0.008 times the 10,000, because it's 0.8% of the 10,000 have cancer. $80. Any questions on that? So from the selected women in the group, that 0.8% have breast cancer. Now remember, you need to be able to add across and down. So we can find this value by taking the 10,000 and subtracting 80. Any questions? Because we need to be able to add across. Because this column is total and so is the bottom. So 9,920 of them have cancer. I mean, do not have cancer. I didn't remember recording. I was just double checking. Any questions on the bottom part? Now, when we read the next one, if a woman has breast cancer, so we're saying they do have it, this first column. If a woman has breast cancer, the probability is 90% that she will have a positive test. So 90% of the ones with cancer will have a positive test. 90% as a decimal times the number that have cancer. So 72 of those 80 women will test positive. How many of those 80 women will test negative? Anyone?
8.
Because 80 minus 72, 8. Any questions so far? Let's look at the next one. Sentence. If a woman does not have breast cancer, so if they don't, we're talking about this column, we're only talking about the 9,920. The probability is 7% that she will still have a positive mammogram. So 7% will still test positive. 7% as a decimal 0.07 times the 9,920.
I got 694.4.
Okay, so we'll just round that to a whole 694. Since we're talking about people and tests, we don't want half of a test or part of a test.
Oh, okay.
Yeah, so we'll just round it. I was hoping the 10,000 wouldn't have the decimal, but it still does. Yeah. On a test, if it does end up a decimal, you probably did something wrong. I will try and make it so there's no decimal, or I will put round to the nearest whole number, so that you know if you do get a decimal. Finding the negatives, then just subtract. Any questions? To get the totals, add across. And then add down to double check your answers. Sometimes what happens if we round, like if this was a 0.5 and this was a 0.5 and we rounded up on both of them, then this may be off by 1. And that's why I'll do it ahead of time so that that won't happen. But know that if you were doing a study, that could happen. If both of them end up rounding up, this is going to be 1 too high. Any questions? So the probability cancer given they tested positive. Now tested positive, we know, so that means we're only using that 766 people because we already know they tested positive. So we only use this. And we want the probability of cancer. So those who have cancer is 72 out of the 766. Fractions, Fine. If we went with a percent, 9.4%. Any questions on that? So if a woman tested positive from this group and she's asymptomatic, there's a 9%, a little over 9% chance that she does have cancer. And so we could talk to her and says the chances are low that you have cancer. Yes, we need to test further to make sure, but those who test positive, 9% have cancer. Doesn't sound like a very good test. I think it's because they had such a large amount that didn't have cancer. Any questions on that one? Let's try another one. Number 4. In 1990, a 55-acre landfill in Tonawanda, New York, was found to be contaminated with radioactive waste. The waste is related to the development of atomic weapons during World War II. In the early 1960s, a new neighborhood was constructed adjacent to the landfill. Remediation of the site is underway and is expected to be completed in 2024. Tonawanda is just one of hundreds of sites around the country that were involved in early development of atomic weapons and atomic energy following World War II. Suppose a randomly selected site had 4% chance of being contaminated, and that the sample soil from a contaminated site has a 60% chance of testing positive. And then a soil sample from a non-contaminated site has 18% chance of testing positive. If a soil sample from a randomly chosen site tests positive, what is the probability the site is contaminated? So again, we need to know how many samples they're going to take. In this example, they took 1,000 samples. So we'll go with 1,000. That way, if you want to look through the book at the question, you can. So we're starting with 1,000 samples. Suppose that a randomly selected site has a 4% chance of being contaminated. Soil sample from, okay, that's right. So we have a 4% chance of being contaminated. Suppose that a random select site has. So contamination is 4%. Of the 1,000 samples, there's a 4% chance that they're contaminated. 4% as a decimal times the 1,000. So 40 of the 1,000 samples are contaminated. Any questions on that part? So if this is 40, how many are not contaminated? Anyone?
960.
Yep. 1,000 minus the 40, 960. Check the next one. Suppose that a contaminated site, so we're using that first column. A contaminated site has a 60% chance of testing positive. So contaminated site, 60% chance of testing positive. Go ahead and do this column. Sixty percent of the contaminated ones, 24. Any questions on that? Forty minus 24 is 16.
Wait, so if I did 0.60 times 40, is that okay? Or
Yeah, 0.6
Okay.
times 40 should give you 24.
yeah, it did.
Oh, okay. Yeah. And then 40 minus 24, 16. Because of the 0 after the 0.6, you don't have to have it there, but if you have it, it's still going to give you the same answer.
Okay, I was just making sure.
No, that's fine. Let's look at the next group. A soil sample from a non-contaminated site, so that's the next column, has an 18% chance of testing positive. 18% of the 960. 173. Is that what everyone got? 173 and then 787.
Yeah, that's what I got.
Perfect. And then just add across. And then add down to double check. The only time it may not match is if you rounded, but this one we didn't need to round. I don't think we did. Any questions on it?
Wait, I had to round
Yeah, we did, huh?
the 0.18 times 960
Yeah,
because I got 172.8.
I forgot. I did the calculations yesterday and I forgot we did have to round here. Any questions on that one? Okay, let's see, what did the question say? If a soil sample from a randomly chosen site tests positive, what's the probability it's contaminated? So we want the probability contaminated. Given tested positive. So we're given it's positive again, so we're only using the row for positive. The probability it's contaminated. (24 out of 197). (12.2%). find one more probability. The probability it tests positive given it's contaminated. Because I think that's an important thing. If they're in an area that's contaminated, we want to see how much it's going to test positive. These two are not the same thing because what you are given is different. Since you're given contaminated, you're only using this column. So then testing positive is 24 out of 40. So of those that are contaminated, we are finding 60% of them. So there's still 40% that are contaminated that we are getting a negative test for. Is there any questions on that? Okay, if you do not have any questions, I have a meeting to go to. So I will see you tomorrow, but is there any questions?
No.
Okay, then have a nice day.
Thank you, you too.